I'm involved in this project because I want to be at the front ends of technology.
It is a very big project, ambitious, due to trying to develop a new technology.
On this project, working with the other partners has been, personally to me, the highlight of my career.
The scale of Lasimm, the potential of it is that it's demonstrated these parts and the process.
The idea of Lasimm was actually to go bigger than what we have in the market at the moment.
Additive manufacture represents a way to add value to steel parts, reducing the weight of the parts or increasing the strength of the parts. You can also add value through complexity, so being able to 3D print parts that you couldn't otherwise produce through casting or through milling alone.
So additive has been growing incredibly, but the industry is, in order to implement it, is asking for other type of solutions. And one of them is making sure that in the same machine they are able of additive and subtractive.
A PKM is a parallel kinematics machine based on parallel kinematic technology to achieve a movement and good capabilities in terms of rigidity and accessibility for different processes like milling, drilling. The advantage of having a PKM machine in Lasimm cell is the terms of flexibility of the robot, in terms of degrees of freedom, the movement of the milling machine and the speed that can be achieved.
So the idea was to have very large hybrid machines. When I mean large, the objective of the partners in this project were to do a 6 meter by around 2 meter side working envelope.
This cell focuses on a certain geometry of parts, but the technology itself is so applicable, you can make anything.
The robots themselves are R2000 IBs. They give us a really long reach. The welders that we put on there are Fronius CMT, very controllable, very stable. The positioner was made from scratch. The gearboxes and motors were bought from a manufacturer. The track itself came in with the robots. It's driven as 7th axis for the robot, and it's servo motor controlled along a rack and pinion.
If you look at the market industrial implementation of AM, we already see parts with enough quality to be able to be used by industry, being it in planes, being in cars or ships. Different sectors, industrial sectors, have already been able to achieve, using additive manufacturing, the quality levels required.
One of the key values that additive manufacturing can bring to the sector is the ability to fabricate components on demand. So this is the ability to produce one-offs as and when they're needed.
If you want to make a one-off component, additive is a very productive way to make the one-off.
The technology involved in this project will be disruptive to the industry because it will save time, money, waste. Here you produce just what you need and remove very little.
So the construction sector, it is slowly embracing additive manufacture at a larger scale. For a long time it's used small 3D printers, but the scale of this is now shifting to larger components which can be used directly for buildings.
The outcomes of the project will be used in the 3D printing industry. To me, the ultimate would be to see a large part on this machine finished.
I think within 10 years I hope to see this closer to production capacity. This means that it has to move from universities through to actual commercial startup companies adopting the technology and being able to offer the service to any customer.
We were very lucky to be joined by different partners, like Fossil Partners from construction, BAE Systems from the defense sector, investors from wind towers sector. We also had very much leading research organization working with us, Cranfield University, HGG from Germany, and IST from Portugal. On the hardware side, we had companies like Lasimm, Global Robots, and Autodesk that was responsible to develop the software that could make this machine work. And final, not forgetting the left,